Welcome in Core. Space is seemingly endless, harboring an astounding amount of galaxies where life could possibly exist. But just imagine for a moment being in the vastness of space. Your life has just begun. No Earth, no air, and no planetary gravity to hold you down or restrain you. You are simply born into the cold, black, and unforgiving conditions of outer space. It sounds a little lonely and a bit scary, but what would it really be like to be born in outer space? Ever since November 2001, humans have been living in space, but only for brief periods of time. Every single human being has been born on Earth, so it's purely speculative to answer a question about how or if human bodies would survive being born in space, because truthfully, the possibility is too far-fetched for many reasons. First of all, a pregnant woman would not be advised, nor are they currently permitted by NASA, to travel into space. In fact, astronauts must be in top physical shape to withstand the rigors of space travel. Before liftoff, they are required to undergo elaborate survival training, and they also go through rigorous physical exercise and intense medical exams. Furthermore, learning how to walk in space takes place underwater and requires a lot of stamina and endurance. For a very fit athlete, these challenges are difficult enough, but being pregnant would probably render an astronaut incapable of performing any of these tasks. Secondly, if an astronaut weren't already pregnant, conception is nearly impossible in space. The weightless environment would be a challenge for couples to stay attached. They would have to be anchored down not only to the space vehicle itself, but also to each other, which would be extremely awkward. Fertilization of an egg would be nearly impossible within a weightless environment. Even if it did happen, fluid flow to the embryo would also be interrupted, making it nearly impossible to gestate and develop a baby to full term. To be more specific, the underlying question about being born in space is related to the effects of weightlessness on the human body. Many astronauts who go into space and who are currently living on the International Space Station go through tests to measure the effects of weightlessness on the human body. However, it is not known what the full effects are. The closest we've come to determining the answers to those questions is a study done in 2001 on 20 pregnant rats that were sent to space and returned to Earth to give birth. The mother rats all gave birth to normal-sized babies. They were able to lactate to feed them normally and did not suffer from significant loss of muscle mass. The rat babies, however, had trouble righting themselves after being turned on their backs, but they eventually were able to do it after 5 days of trying. Earth-born rats were able to right themselves immediately. This suggests an anomaly in the inner ear system of the space rats that Earth rats did not have, but that's literally the only conclusion from this elaborate experiment and doesn't tell us much at all. One of the primary scientific facts is that all fluids are affected in a major way by the lack of gravity. As you know, our bodies are made up of approximately 60% water. With all this fluid being pulled down by gravity on Earth, the body reacts in ways that are familiar to us. However, in a weightless environment with no gravity, bodily fluids are not being pulled down and instead are free to float around the body uniformly. Free-floating fluids in our bodies make our bodies behave differently than they do under normal gravitational circumstances. We already know what the specific effects of this are from years of space travel and astronauts' first-hand experiences. More than half of astronauts suffer from space sickness, which is caused by fluid expansion in the inner ear that happens in a weightless environment. The effects of these fluid shifts vary from mild nausea and vomiting to disorientation and intense headaches. It's difficult to imagine being able to gestate a baby while suffering from both space sickness and motion sickness. Astronauts in space also experience swelling in the ocular cavity, which leads to optic nerve issues and creates a bulging eye effect. Astronauts also experience a phenomenon in zero gravity whereby tears don't actually fall, while in space, tears just well up in a ball around the eye until they are wiped away. There is also a condition called chicken leg syndrome. On Earth, the heart pumps blood against gravity in order to force blood to the upper parts of the body. With no gravity to pull fluids down, they remain in the upper body. All that fluid above your heart creates a puffiness in your face and, conversely, chicken legs. A pregnant woman who has already retained fluids and is gaining body weight would have trouble sustaining the extra weight while blood is not flowing normally to her lower body. And even more important than the cosmetic, temporary, physical, and visual issues, fluid expansion in the body in a weightless environment causes the brain to mistakenly think that the body has too much fluid. Because of this, the body would produce less blood. Astronauts have lost up to 22% of their total blood volume in space, and blood loss causes weakened hearts. Now, with an understanding of the effects of our bodily fluids changing within a weightless environment, it is possible to take precautions to counteract those effects. With proper pre-flight training, diet, exercise, and medications that are still being developed, we might be able to counteract those weightlessness issues. We could then really begin to figure out what you would look like if you were born under these unusual conditions. There are many other things to consider. If you were born in outer space, you could end up with bulging eyes, develop skinny limbs from lack of muscle growth because of weightlessness, and you might not be able to walk or lift anything heavy at all. The human skeleton wouldn't be able to develop normally, and you would likely suffer spinal expansion due to the loss of heavy gravity. Without normal activity and exercise that human bodies are accustomed to with all that fighting gravity, a child's skeletal development could be severely compromised. Without strong bones, and not to mention a lack of vitamin D, a child born in space would likely be somewhat deformed and probably would never, ever learn how to walk. Another major factor to consider in this equation is exposure to high levels of radiation. Astronauts in the International Space Station are subjected to as much radiation in one day as humans on Earth are exposed to in 1 year. To make matters worse, radiation in space is different from that on Earth, and the effect of cosmic rays on humans are still being studied. But we do know that the effects of radiation on the human body are very detrimental, increasing risk for cancer, damage to the central nervous system, cardiovascular disease, and irreversible damage to cells. These risks could be increased for a vulnerable newborn baby, and growth and development of a child would be stunted. Survival rate under these conditions would be low. If you were born in some similar futuristic situation in outer space, you would never, ever be able to go outside. Your body, despite being born in space, would still be that of a human. Our human bodies cannot exist in outer space without an elaborate spacesuit. This means that as you were raised after being born there, you would never be able to step foot outside nor breathe fresh, clean air under protection of the Earth's atmosphere. You would be relegated to the confines of the space station-controlled environment on which you were born. An impetuous child who impulsively decided to ignore parental instruction and venture outside would die almost instantly in outer space. A kid who went outside to play with no spacesuit would lose consciousness almost immediately because of the lack of oxygen in space. Once you passed out, the lack of air pressure would cause an embolism in your body, which is a formation of gas bubbles and bodily fluids. Because of the lack of environmental pressure, you could swell up to almost twice your normal size. As if all that wasn't bad enough, UV rays, X-rays, and gamma radiation would scorch what's left of your young body. If your parent or guardian discovered you playing outside the spaceship, without your spacesuit on within a minute or so, you just might survive. At some point, a human being born in space might want to return to Earth, and there is no telling how or if you might survive the trip to Earth. And if you did, there is no telling how your body would adapt to Earth's atmosphere, gravity, and environment. Many of the physical developmental challenges we discussed earlier would come into play with a return to earthly living after being born in space. There is a possibility that the skeleton would not have formed properly, muscles that we need on Earth for standing erect and walking may not have developed, and fluid expansion in the body that happens in space would be the norm for you since you were born in space. But how would that fluid pressure change affect you when you experience gravity for the first time? And of course, you probably know the plan for humans to go to Mars. It would be interesting to see the effects of the Martian planet on the human body compared to someone that is born on Earth. We are wonderfully fit for Earth, but space is inimical to our species. Earth's magnetic fields and atmosphere shelter us from the ionizing radiation that streams through space like a fatal wind. On the surface of Mars or aboard a spaceship, long-term exposure to the highly charged energies of galactic cosmic radiation or the sudden flares of solar particle events would kill cells and make them malfunction or break strands in our DNA. And then there's a question of whether or not Martian microbes would make humans sick. Although it's unclear if there are microbes lurking on Mars, truthfully, we are a long way from determining if a human can give birth in space, and we know even less about how our bodies would grow and develop outside of the Earth's atmosphere. There has not been much research outside of that on rats, and frankly, it's such a far-fetched concept, it's no wonder we can't really answer the question with any accuracy. We hope you enjoyed this video. What do you think would happen if you were born in outer space? Let us know in the comments. And if you enjoyed the video, make sure to subscribe and turn on notifications. If you have a good idea for a video, we'd love to hear about it. Thanks for watching Darko, and we'll see you next time.